and welcome to this video on rational exponents and rationalizing the denominator. Our first example, we're going to look at the quantity negative 64 over 27, that whole fraction including the negative, raised to the negative 2/3 power. So anytime we have a fraction in the exponent, as we do here, we can rewrite this using a square root or cube root, a radical notation. And so the number that we have in the denominator of our fraction is telling us the index of our root. In this case, we've got a 3 in the denominator, so that means we're going to be looking at a cube root of what's inside the parentheses, negative 64 over 27, and then the number in the numerator is giving us the power that we're going to raise that expression to. So the cube root of negative 64 over 27, well, we can split that up and just look at the cube root of the numerator and the cube root of the denominator. Remember, if we have an odd root, we can take the root including a negative number, because you have a negative number raised to an odd power, you get a negative number. So going backwards, we can still have negatives underneath a cube root or a fifth root anytime we have an odd index there. And the number that multiplies by itself 3 times to give us 64 is 4. And with that negative, that means that that numerator, the cube root of 64, is going to be negative 4. And the cube root of 27 is 3. So the cube root of negative 64 over 27 simplifies to negative 4 over 3. We still have that negative 2 power on the outside. Remember, a negative in the exponent means that we're going to flip our fraction, put everything that's in the numerator in the denominator and vice versa. So that negative in the exponent is going to flip that and make it 3 over negative 4. And then now it's raised to the positive 2 power. The negative could, in this case, could go out front, be on the top, be on the bottom. It doesn't matter. I'll go ahead and just leave it since it's written with that negative on the 64 from the beginning. I'll keep it there. And then our last step here is to square it. Remember, if we have a fraction, we can square the top, square the bottom. 3 squared is 9. Negative 4 squared is a positive 16. Negative times a negative is going to be a positive. And this one, since there's not any x's or y's or anything in there, you could check this one in your calculator by typing it in exactly as it shows on at the beginning, and it should simplify to 9/16. All right, now let's look at an example of rationalizing the denominator. Rationalizing the denominator is a way to make something in a little more simple isn't necessarily the right word, but in a form that is considered a better form. And the reason for this goes back to the slide rule, which predates the calculator, and not a technology that is used much anymore, but the technique still holds, and it is something that the technique you will use later on. So the first one we're going to simplify. We've got 1 over the square root of 14. We don't like having the square root of 14 in the denominator. 14 is not a perfect square, so the square root is an irrational number, meaning it goes on forever, never ending, never repeating decimal. What we want to do is change that. In the denominator, we want it to be a whole number. And the easiest way to do it is to multiply by whatever is going to make this a perfect, in this case, a perfect square. This is a square root, and so the easiest way to make this a perfect square is to multiply top and bottom by the square root of 14. What we do to the bottom, we have to do to the top. If we multiply that, the square root of 14 times the square root of 14, that's going to simplify in the denominator to the square root of 14 squared. In the numerator, 1 times the square root of 14 is the square root of 14. And the square root of something squared is going to be the absolute value of what we have inside. In this case, it's a 14. And so we get the square root of 14 over 14. And that is considered a more simplified form than 1 over the square root of 14 because we don't have an irrational number in the denominator. Right? That's how we approach it if we have just one term in the denominator. If we have two terms in the denominator, like we do in this next example where we have 5 minus the square root of 6 over 9 plus 3 square roots of 6, we can't just multiply it by that square root of 6 because we'd have to distribute it to the 9 and we would end up still having a square root of 6 in the denominator. We don't want that, so what we're going to do is we're going to multiply by something called the conjugate. And the conjugate means that we have a conjugate pair is something that is in the form of a plus b and a minus b. The numbers are exactly the same. The only thing that changes is whether we're adding or subtracting in the middle. And if you remember from our factoring and polynomial work, if we multiply this out, what's going to happen is we're going to get a squared plus ab minus ab minus b squared. And our plus ab and minus ab is going to add to 0. And so we just get a squared minus b squared. And so since we're squaring each of those terms, there will not be any irrational numbers that will be left. So our goal is to multiply by the conjugate. So this one is 9 plus 3 square roots of 6. We're going to multiply it by 9 minus 3 square roots of 6. What we do to the bottom, we have to do to the top. We do have binomials here, so we are going to have to multiply this out, expand, distribute, FOIL, whatever the word is that you use. 5 times 9 is 45. 5 times negative 3 square roots of 6 is negative 15 square root of 6. Negative square root of 6 times 9 is negative 9 square root of 6. And negative square root of 6 times negative 3 square root of 6, negative times a negative is going to make that a positive. Outside the square root we have a 3. Inside the square roots we've got 6 times 6. Remember, when you're multiplying with square roots, you multiply what's outside by what's outside and what's inside by what's inside. In the bottom, we're going to see 9 times 9 is 81. 9 times negative 3 square root of 6 is negative 27 square root of 6. 3 square roots of 6 times 9 is a positive 27 square root of 6. And 3 square roots of 6 times a negative 3 square roots of 6. 3 times negative 3 is negative 9. Square root of 6 times square root of 6 is negative, or square root of 36. And we see, just like we saw in the conjugate example with the letters up there, we are going to get that those middle terms are going to add to 0. In the numerator, we've got 45, negative 15 square root of 6, and negative 9 square root of 6. Those are like terms, so we can combine those coefficients. Negative 15 minus 9 is negative 24 square root of 6. And then 3 times the square root of 36. Well, square root of 36 is 6 times 3 is 18. In the bottom, we've got 81. Our inside and outside terms are adding to 0. And then we get negative 9 times the square root of 36, which again is 9 times 6, or 54. So if we add like terms, that's going to be 63 minus 24 square root of 6, and then 81 gives us 27. And we do have a common factor. Let's see, 3 goes into all of them. 9 does not, so we're going to stop there, divide each of those 3 terms. by 3. When we divide everything by 3, 63 divided by 3 is 21. 24 square roots of 6 divided by 3 is 8 square root of 6. And then 27 divided by 3 is 9. And you can either leave it like that, or you can split it up and write it as two fractions. 21/9 minus 8 square root of 6 over 9. That will allow you to reduce just a little bit more, which is going to be 7/3 minus 8 square root of 6 over 9. Both of these, depending on the situation, would be considered simplified. All right, I'll see you guys next time.